Hello and welcome to this video on period 3 elements, and the particular period 3 elements that we need to study are sodium, magnesium, aluminium, and also silicon, phosphorus and sulfur. So they're the three non-metals and the three metals that we're going to study in period 3. So let's start off with how they react with water. So the reactions with water, and as it happens, only the metals react with water. All right, so we're going to have a look at sodium first, and then magnesium. Let's look at sodium first, and we're familiar with that reaction. That is sodium plus water, and that makes sodium hydroxide, and also hydrogen given off, hydrogen gas given off. So let's just balance that with a half in there. So then it's all balanced. Now this is a fast reaction, so let's change colour so you might remember it. It's a fast reaction, and when sodium hydroxide is in solution, it's very soluble. It's very soluble, which means you get lots of hydroxide ions. Lots of hydroxide ions, which therefore means it's very alkalinic. So it's very alkalinic. In contrast, when magnesium reacts with water, there is a reaction. It's very slow. It's imperceptible to the eye. But the reaction follows the same pattern, leading to magnesium hydroxide and hydrogen. In order to balance this, we're going to need two waters there. So that's the reaction. Magnesium plus water gives you magnesium hydroxide and hydrogen as well, but it's imperceptibly slow. So let's note that. Right. So this reaction is slow, and what's more, the magnesium hydroxide. This magnesium hydroxide is almost insoluble. So almost insoluble. It's almost insoluble, so the result of that is that there are few hydroxide ions, and therefore not very alkalinic. Not very alkalinic. It's only weakly alkalinic. However, magnesium does react with steam. It does react better with steam, because steam has more energy. So steam has more energy. And the energy is useful because the ionic bonds in magnesium are stronger than sodium, for example, because magnesium is a 2+ ion. And so the activation energy is higher because of those strong metallic bonds. And steam does have more energy, and so provides some of that activation energy. Nevertheless, you still need to heat the magnesium in order to make it react, and when it does react, you get a slightly different reaction. So you get magnesium plus water, giving you magnesium oxide this time. So you get magnesium oxide and hydrogen. But you still have to heat. The magnesium to make it work, to provide the rest of the activation energy. So that's the reactions with water and steam of the two that do react, which are sodium and magnesium. Let's now look at the reactions with oxygen. Okay, so I'll come off this side for reactions with oxygen this time, and this time all of them react with oxygen. So let's come around here to first look at sodium's reaction with oxygen, and we get sodium plus oxygen. It's going to make sodium oxide, formula of which is Na2O, and to balance that we need a 2 there and a half here. And let's, while we're at it, put the oxidation state of sodium in here, see if there's a pattern. And this reaction is vigorous, right? As you might expect, it's vigorous. And the flame color is yellow, right? So it's vigorous with a yellow flame. Okay, so that's the sodium reaction, and let's do the magnesium reaction as well. So we can do the magnesium reaction up here. So when we react a magnesium with oxygen, you get magnesium oxide, also very vigorous. So this is the one you might have seen in class when you put the little tints in front of your eyes, so your eyes don't get hurt by the brilliant white flame. So brilliant white flame. And these colours are useful because they allow us to identify the metals. And the oxidation state of magnesium is +2, which is a normal oxidation state. Okay, so that's the magnesium reaction. Let's do the next one. Let's do aluminium. So when aluminium reacts, and it needs a lot of encouragement to react because those metallic bonds are even stronger. So it does react under the right conditions with oxygen to make aluminium oxide, like so. And you can see from that formula that the oxidation state of aluminium is going to be +3. But this is a slow reaction that would require a lot of encouragement in the form of heat. We should just balance it. So we would need 2 of those and 1.5 of those to balance. So that's a slow reaction, and consequently we don't get a flame. So we won't be identifying that by the flame color. And that's the same situation as with the next one, which is silicon. So when silicon reacts, if you give it enough encouragement, it will make silicon dioxide, which is a very stable compound, very high melting point, and also insoluble, as you know, because silicon dioxide is a major component of sand, and sand doesn't melt in the sun, and it also doesn't dissolve in the sea. So oxidation state of silicon and silicon dioxide +4, as you might expect, being in group 4, and that we should say is a slow reaction as well, so no flame. Okay, and that's the silicon one. Just 2 more, phosphorus and sulfur. So let's do phosphorus here in the corner. So phosphorus solid exists as P4 molecules, and that could react with oxygen. All right, and it's actually going to react with 5 of them to make P4O10. Crazy big molecule. And working out that oxidation state of phosphorus is +5 also, as expected, phosphorus being in group 5. Now that is a nice reaction. It's a spontaneous reaction. So let's write that up here, spontaneous. And it also, like magnesium, is brilliant white. It's a brilliant white flame and reaction that you get there. And so that's the details of the phosphorus reaction. Let's do the last one, which is sulfur. And the sulfur reaction is slightly different. It's slightly different. You still get an oxide, sulfur dioxide as it happens. And this time you can see that the oxidation state of sulfur in the oxide with this reaction at least, is +4, but sulfur's in group 6, so that's why it's slightly different. In order to make SO3, all right, so SO3, sulfur trioxide, that requires high temperature and a catalyst. That requires high temperature and a catalyst, and we're doing the sort of normal oxide reactions here. And when that burns, when the sulfur burns, we see a steady reaction. It's a steady flame, but it's a very nice blue color. Right, so it's a steady reaction with a blue flame. There we have it, and that is what you need to know for the period 3 elements. Some more you need to know for the oxides, but that's in a different video.